friends, today we will study one very important topic in exam point of view. Many problems are asked in entrance exams, and that is power series expansion of a complex function. By understanding this topic, we can find and solve the problems based on Taylor series, Lorentz series, and we will also be seeing in this topic the radius of convergence of a power series and region of convergence of a power series, and these are very important topic in exam point of view. One or two questions are always asked, so we will just see what we have to remember in this topic, and then we will solve some problems. So the definition of defining the power series is that every analytic function which is analytic at z equals z0 every analytic function which is analytic at z equals z0, it can be expressed in terms of power series about z equals z0, and the structure of such power series is given by n equals 0 to infinity a n. Since it is about z equals z0, it will be z minus z0 to the power n. This is the structure of the power series, and if you expand it, then it will be just a0, put the value of n. So first term will be a0, and this term to the power 0, anything to the power 0 is 1. Then you put the second, so let's find the second term, so put the value of n to be 1, so a1 z minus z0 to the power 1, it is just this. Then the second term will be a2 z minus z0 to the power 2, and so on. a0, a1, a2, they are called the coefficients, and z0 is the center of power series. And for every power series, so this is the general structure of power series, we should note that. And for every power series, there are three possibilities regarding the region of convergence. So that we are going to see for every power series. There are three possibilities. Regarding the region of convergence of power series. Region of convergence means the region in which the power series converges. Converges, that means the power series tends, the value of the power series tends to 0. And region of divergence means the region in the plane in which the power series diverges. Diverges means the value of power series tends to infinity. Here we are concerned with the region of convergence. So the region in which the power series converges. So there are three possibilities about the region of convergence. first possibility is that the series converges within a disk. So the example of that is, let's say that we have a function like z to the n. If we expand it, then n, so z to the 0 is nothing but 1, z plus z square, and so on. Now we use the test formula here, and that is Tn plus 1 upon Tn, which is equal to z to the n plus 1 upon z to the n, and this will be z, right? Z to the n plus 1 upon z will be z. So for z less than 1, the series will converge always. This is to be remembered. The series will converge. That means it will converge within the circle centered at the origin with unit radius. So unit radius means, so you have a plane, and in that plane, so this is x and y, this is the origin, so, and this is 1, 2 and so on. So it is centered at origin with the unit radius, means with the radius 1. So here will be the minus it's like this. So your disk will be like this, okay? And the region of conversion is within the disk. That means the series will converge in this radius, in this region, okay? So therefore this type of convergence is called the series converges within a disk. So there are some series which will converge only within the disk and not outside. So this is the first kind of series which converges within the disk, and in this case the radius is 1, so it will converge within this particular circle. So there are some series like this. Then there is one other way, the second method, the second way, the second case of the convergence of the series is that it will converge in the entire complex plane. So the power series converges in the whole complex plane. For example, let's say you are given a function like z to the n upon z n factorial. Then if you expand, then you will get as 1 plus z square by 2 factorial plus z cube by 3 factorial and so on. And here again you do the test. In case you don't know the test methods, that is fine, you just need to know this relation only. So you can remember from here that you just have to do this test of z to the n plus 1 upon z to the n. And since here you will, so your tn plus 1th term, okay, these terms are called t1, t2, t3, t4 and so on. So tnth term will be z to the n upon n factorial, so z to the n upon n factorial, so this will be here, and t to the n plus 1th term will be z to the n plus 1 upon n plus 1 factorial. Okay, so this will be like this, n plus 1 factorial. So when I write tn plus 1 upon tn, that means the n plus 1th term and nth term. You just have to put the values of those terms and see what you get. So you see here that this will be equal to z to the n plus 1 into n factorial upon z to the n, and n into, means it is n plus 1 factorial will be n factorial into n plus 1. So you see here that you are left with z, just a z upon n plus 1. Okay, and now you observe this, that z upon n plus 1 will tends to 0 as n tends to infinity, because if n tends to infinity, that means infinity plus 1 is infinity, so whole denominator is infinity, and 1 upon infinity will be 0, right? So as n tends to infinity, this whole term will tend to 0, and when something tends to 0, that means, as I said, the series will converge. Okay, so this will happen for all values of z I mean, that is, the series will converge in entire complex plane, right? Because this is valid for all z, that means whole complex plane is involved and it will tend to 0. So therefore we say that the another type of power series are such which are which converge in the whole complex plane. Earlier we saw the case in which the series was converging in within just one disk, and here the series converges in whole complex plane because it is valid for all value of z. Okay, and then the third type of convergence is that the power series converges for just one particular value. So for a particular value of z, for example, you are given a function like n factorial into z to the n, then if you expand, then we will have something like this, and again we do a test, tn plus 1th term upon tnth term, then n plus 1th term will be n plus 1 factorial plus z to the n plus 1 divided by n factorial into z to the n. Now n plus 1 factorial can be written as n factorial into n plus 1 into z to the n plus 1 upon n factorial into z to the n. If you are comfortable here, you can do the quick calculations. I am just doing this in case you don't know it. So n plus 1 into z will be the answer, and here if you notice, then this n plus 1 into z will tends to infinity as n tends to infinity, because if n tends to infinity, then n plus 1 will be infinity, and infinity multiplied by anything will also be infinity. So when n tends to infinity, this whole term will tend to infinity for all values of z except z equals 0, because if z equals 0, then your answer will be 0, and if that is 0, that means the series is convergent now. So that means the series will converge only for z equals 0. So this is this third type of convergence in which the power series converges only at the particular value of z. So there are these three type of convergence for the power series which we should know, is that it converges within a disk like this, or it will converge in the whole plane, or it will converge only at a particular value of z. Like in this case, it converges only at the point of origin, and it will diverge everywhere in this case. Now once we know this, it is very trivial and very quick to understand the radius of convergence. So just consider a circle just like in the previous case, which is centered at z equals z0, and radius is r, that is z minus z0 is capital R, such that, now this is very important, such that the power series is convergent for all points of the region z minus z0 less than r, that is within the circle, because it is, if this is the radius, then it is convergent within r, that means inside the circle, not outside. So this r is such that the power series will tend to 0, that means the power series will converge within r, and it will diverge outside the region of r, that means outside the circle, and is divergent, the power series is divergent for all points of the region z minus z0 greater than r, that is outside the circle, and therefore r is said to be the radius of convergence of the power series and is defined as r equals limit n tends to infinity an upon an plus 1. I told you the coefficients. An is the coefficient of the power series, so it is this. So this is just a formula for finding the radius of convergence. So it says that if let's say we have a plane and we are given, so let's say this is z0 and this is the radius of the circle, then for the region, this region is z minus z0 which is less than r, and in this case the power series will be converge, power series. And in the outside region, everywhere outside this circle, which is the region z minus z0 greater than r, of course it is greater than r, and the power series will diverge. So r, this radius of convergence, is the bridge between the convergent region and the divergent region. So if you just cross this circle inside and you come inside, then you will be seeing the power series is converging, and outside the power series is diverging. So this is just the divider between the convergent and the divergent region. So once you define the radius of convergence r, and you now know that within the r the power series will converge and outside the r the power series will diverge. So when in the question you are asked to find the region of convergence, that means you first find the radius of convergence by using this formula. Once you know, let's say suppose r equals 1 is the radius of convergence, then you will say that z less than 1, because z less than r is the region of convergence. Okay, z less than r is the region of convergence. Here I have just taken z0 equals 0, so it is just like this, z minus z0. So if z is less, so if r equals 1, if you find that r radius of convergence is 1, that means that the region of convergence is this, for less than 1.